So today we're going to be talking about integers, opposites, absolute values, and the inequalities. And so we're going to start with what are integers. Well, integers are numbers that are both positive and negative and zero. So for example, the numbers -3, and there we go. So for example, the numbers -3, -2, -1, 0, 1, 2, and 3 are all integers. So any number that is positive, any number that's negative, and 0 are all integers. And they have to be whole numbers. So you can't have fractions, you can't have decimals, you can't have any number that's a part of a whole. It has to be a whole number. So -10, -20, 412, 9,387, those are all integers. And so now let's talk about opposites. Well, opposites are actually very fundamental. And so, for example, the opposite of 2, which is this guy right here, is -2. Okay? The opposite of 412 is -412. And so we can also use this on a number line. So for example, and this will take a moment, but let's say I have -4, -3, -2, -1, 0, 1, 2, 3, and 4. And I have this on a number line. So if I draw my number line up top, and I'm going to use a different colors for this. The opposite of -4, which is this guy right here, we can simply go however many spaces to the right to 0, count out how many spaces we went, and then go that many spaces past 0. Or you can simply just say, well, the obvious thing is if you have a negative sign in front of it, take off the negative side. If you have a positive in front of it, or if it's a positive number, just simply take the negative of it. But you can count out 4 spots and then go 4 additional spots, and you get to your opposite counterpart. So to restate that, the opposite of -4 is 4. You can simply just get rid, and I'm going to use a little X here, you can get rid of that negative sign, and it becomes 4. Additionally, if we have a positive, since we've been talking about negatives, if we have a positive, and let's say we have 312, the opposite of 312 is simply -312. Okay? And so, why are we learning this? Why are we learning about integers and opposites? Well, they take precedence when we're talking about absolute value. And so when we're talking about absolute value, let me go to a new page here. Absolute value is something very important. And so let's see, absolute value. Now, the absolute value of any number is the distance between that number and 0. So for example, if I'm looking for the absolute value of 5, which the absolute value, by the way, is denoted by these 2 bars. So it's denoted, this is not formal lingo, but it's denoted by the 2 bars. The absolute value of 5 in this case, we would look at our number line, we would start at 0, and we would count out to 5. So we'd go 1, 2, 3, keep going a little bit more, go to 4, then go to 5, and we would count out how many spaces that is. How many numbers did we come across? So we would count 1, 2, 3, 4, 5. And so then the absolute value of 5 is simply just 5. Additionally, if we're looking at the absolute value of a negative number, let's say -2, just for simplicity, we would create our number line, we would start at 0, and then we would count how many numbers we get to -2. So we would go -1, -2, and then we simply just count the spaces 1, 2. And so -2 becomes 2. For some of the more advanced people here, we can say that, and if you're starting to catch on, the absolute value of, let's say, -14 is simply just 14. The absolute value of 317 is simply just 317. Now, this isn't too common, but you can see this, is we can also do the absolute value of non-whole numbers. So for example, fractionals, decimals, or really any real number. So for example, the absolute value of 23.127 is simply just 23.127. If you're looking at the absolute value of -142 and 4/9, it's simply just the positive of that, which is 142 and 4/9. Now, one last thing we're going to go over is inequalities. So let me go to a new line, new page here. There's my new page. And we'll talk about inequalities. So inequalities, if we recall from elementary school and maybe middle school and a few other ones, inequalities are the less than sign, the greater than sign, less than or equal to, and greater than or equal to. Now, these signs depend, and the naming of these signs depend on what you are using them in context. So, for example, if I'm looking at two numbers and I'm saying which one is bigger, 6 or 4, we would say 6 is greater than 4. Okay? On the opposite hand side, if we're looking at 2 and 7, then we're saying 2 is less than 7. Okay? And if we're looking at these next set of numbers, let's look at 15 and 23. We see that 15 is less than 23. And so we use the less than symbol. It's always based on whichever number is first. So, yeah, usually if this number is bigger, then you're going to use the greater than symbol. If this number is smaller, you're going to use the less than symbol. So we have a couple of examples that I just want to go over quickly, and then that will be this video. We're going to look at the difference between 3 and 5. We're going to look at 10 and 19. And then we're going to look at 21 and 7. And so, looking at these guys, 3 is less than 5, 10 is less than 19, and 21 is greater than 7. And so those are inequalities. Later on, we'll get to two new symbols, well, two symbols that we didn't cover here, which is the less than and equal to, and actually I'm going to use my white for that. We're going to get to less than or equal to and greater than or equal to in a different chapter. But basically they're making an comparison that's saying that this is less than or equal to something else. But we'll get to that later. And then there's also an equality symbol that you may see later, where we say that two things are the same. So a brief example of that would be, let's say, this may be a little advanced, but let's say 4 and 7/7. That is actually equal to 5, because 7/7 is one whole, and then you have the 4, and technically you just add those two together and you get 5. But that's for a different video.